Welcome to our video tutorial for question 6 of our daily review. Question 6 is talking about solving algebraic equations. And before we describe what algebraic equations are, the steps to solve algebraic equations, and look at a few examples of that, I want to just tell you first that this is probably one of the very most important things that we do all year long. It's incredibly important. It is something and a skill that you are going to use in this math class and every class that you are ever going to encounter that's a math class from here forward. It doesn't matter if it's really complicated math or simple math. We constantly use this skill. And so learning this skill this year is extremely important. It's going to be really important that you continue to practice this and that you are able to come back to this question week after week in the varying complexities as these problems become more challenging or sometimes less challenging, and make sure that you're solving these correctly. So feel free to come back to this video at any time and look for the new parts, the new things that we haven't experienced yet or talked about in class yet. And then just make sure that you're also asking questions throughout the year, because we want to make sure that you are able to do this skill very well by the end of this year. So let's go ahead and talk about what we mean when we're describing solving algebraic equations. Well, algebraic equations are going to be an equation with something that's unknown inside of that equation, and that's going to be represented with a variable. So when we describe solving the unknown equations, that means that we need to find what the unknown values or the variables are worth in that particular equation. And we will do some examples of these today. Now, when we are solving our algebraic equations, or I should say before we can solve our algebraic equations, we always need to simplify first. We're always going to look to see if there is anything we can do to simplify that equation, to make it both easier to work with, but also to make sure that we know the order of the steps to walk through when we are solving. If we don't simplify first, sometimes we can run into some roadblocks in terms of what steps we are supposed to be doing in what order. So there are a couple of things we're going to look for when we simplify. The first thing I'm going to encourage you to do is to distribute. You're going to use the distributive property anytime that can be done in those types of problems. And again, we will look at these types of problems. After you've distributed, or if there is no distribution left to do, you're going to combine any like terms. That means any types of numbers, variables, or parts of the equation that are the same, you're going to put them all together. That includes putting our positives with our negatives and making sure that we have the correct value when we put those positives and negatives together. Next, we're going to always make sure that our variables are only on one side of the equation. They're not always given to us just on the left or just on the right side. Sometimes we have variables on both sides of the equation, so we want to make sure that we move them to one side of the equation. Once you've simplified, then you are able to use the inverse operations to isolate the variable. And when we say isolate the variable, that just means that we're getting the variable all by itself, or in this case, we are simply solving that equation. That is what we are doing. And a quick reminder that when we use the inverse operations to isolate the variable, what we are really doing is we are undoing the math problem that is there before us. And we have to think about this as undoing, because that determines the order that we're going to work in when we encounter these problems. And we'll talk about that when we go through some of our examples here in a moment. But that word undo can be really helpful. Let's go ahead and take a look at some examples The first thing that we're going to take a look at are one-step equations. Now, the nice thing is that one-step equations never need to be simplified because there's only one step left for us to do. So in this case, these problems have already been simplified. They are already in the simplest form. Think back to when you learned how to simplify fractions. If you were given a fraction of 1/2, well, it's already simplified. You don't have to simplify it again. That's just like our one-step equations. We always want to look to see if our problem can be simplified, but these ones have already been simplified. So here's an equation that's x plus 7. That equals 13. Most of us probably know the answer to this in our head, but if we didn't know, we could simply solve this equation by undoing. We're going to do the inverse operation. If the operation was plus 7, I'm going to minus 7. And when I minus 7, that gets rid of the plus 7. So now I have a math sentence that's x plus 7 minus 7. All that's left on the left side of the equation is x, and that's what our goal is. We want to get the variable all by itself. And then whatever we do on one side of the equation, we have to do on the other. So now we had 13 minus 7, and that equals 6. X equals 6. And we could always go back and check and see, does 6 plus 7 equal 13? And it of course does, so we know we've got that correct. Let's go ahead and take a look at another one-step example. Here we have 4x is equal to 42. Well, this is a one-step equation. There's only one operation in here, and that operation is multiplication. It's 4 times x is equal to 42, so I need to undo that, and we're going to undo that by using division. So I'm going to divide both sides by 4x. This time, when I divide 4x by 4, I actually create 1x. And when I divide 42 by 4, I'm going to end up with 10.5, or 10.5. X is equal to 10.5. And again, we could check that out by replacing x with 10.5. 4 times 10.5 does in fact equal 42, and that's our goal. We know we did it correct. Let's look at two more one-step examples. If I had w over 9, or w divided by 9, w divided by 4 equals 9, we're going to undo that by multiplying. So that means I'd multiply both sides by 4, and I get 1w is equal to 36. And finally, our last problem, if I had k minus 6 equals 19, I'm just undoing. I'm using the inverse or the opposite operation for all of these. I'm simply going to add 6 to both sides. I'm going to get just k on one side as equal to 25. And again, I can always check my work. Next, let's go ahead and look at some two-step equations. Two-step equations involve two operations. We're going to see an equation with addition and division, or multiplication and subtraction. And that means we've got two steps that we need to work with. So let's go ahead and look at an example here. Here we have 3 plus 9k is equal to 6. In this case, we have addition and we have multiplication. Again, I always want to start by looking to see if I can simplify. In this case, there's nothing I need to do to simplify. It is already simplified. So we're just going to start solving by using our inverse operations. But there's something that's really important for us to remember. And this is why I told us to remember that we are undoing the problem. When we do the problem, we know we have to follow our order of operations. But when we undo the problem, we have to undo it backwards. We have to work our problem out in the opposite order, right? And the way I always like to think about this is I always like to remind us, it's kind of like when you get up in the morning and you're getting dressed. You put your socks on first, and then you put your shoes on. And when you go home at night and you're sitting on your couch watching your TV, you can't take them off in the same order, right? If you try to take your socks off before you take your shoes off, you're going to have a really rough time, right? So we have to go in the opposite order. Well, it's the same thing when we undo a math problem. We have to go in the opposite order. So we know we should multiply first when we do the problem and add second when I'm doing the problem. But that means when I undo the problem, I'm going to undo the addition first. So let's go ahead and undo that addition. I'm going to minus 3 on both sides. That leaves me with 9k on one side is equal to 3. Now I can undo the multiplication because I've already undone that division. I'm going to end up dividing both sides by by 9. That's going to give me 1k equals 3/9, and I could also simplify that to 1/3. Okay, the key to those two-step equations, and this is going to apply to our multi-step equations that we're going to do in a minute, is you have to make sure you undo in the opposite direction. Let's do one more two-step example, a multi-step example here. Okay, now we're starting to get into some problems that are not simplified yet. So we need to simplify. Let's start with an easy step for simplification. This is going to be the combine our like terms step. We want to look for anything in this equation that is the same. In this case, I notice that I have 6k and I have a 13k. Notice that I'm looking at the operation symbol that shows up in front of them. That tells me what I need to do with these particular numbers. But I'm going to know in this case that those, even though the numbers aren't the same, they're describing the same thing. I have 6k, and then I'm taking 13k away. I also am going to notice that I have some just constants. Those are also going to be like terms. So we want to combine those like terms. We want to put them together. Again, remember that we're going to focus on the operation that shows up before it, and that tells us what we are doing in this particular problem. In this case, we have 13 minus 4 is going to give us 9, and we have 6 minus 13 is going to give us 7. Now we have just a two-step equation. This is like what we had in our last problem. It has subtraction and multiplication, and we have to undo it going in the opposite direction of our order of operations. So let's undo it going opposite of order of operations. That means I have to get rid of my plus 9 first. So I'm going to go ahead and get rid of my plus 9 by minusing 9. And then I can get rid of my divide by 7. I ended up with 7k equals 22. I'm going to divide by 7. And that tells me that 1k is equal to 3.14287. And you could round that if you were asked to round that, or you could also just write it as a fraction as well. That either of those things work. Okay. Now, let's go ahead and look at another multi-step equation. This time, we're going to involve some distributive property. Distributive property, our clue is we see those parentheses. We've got something on the outside of the parentheses that needs to be distributed to the inside of the parentheses. Let's go ahead and look at that. I'm going to multiply my 3 by everything that's inside of those parentheses. In this case, 3 times 4x is going to give me 12x, and 3 times 12 is going to give me 36. And I can write everything else down just like I did in the other part. And then I can continue. Next, I'm going to look for, do I have anything that can be combined or anything that can be put together? In this case, I notice I have some constants. Those can be put together. So let's go ahead and put those together. So my 12x remains the same, but 36 minus 6 is just 30. And that equals 14 plus 34x. Now, I'm going to notice that I ended up with x's on both sides of this equation. I want to get the x's or the variables to just one side of the equation. Now, you can technically move them to either side of the equation. It doesn't matter. The thing I always like to do is I always like to bring the variable to whichever side has the most of those variables on it already. So I'm going to move the 12x's to the side that has the 34x's, and just like we've done before, I'm going to do that by getting rid of those 12x's on that left side, and I'm going to do that same thing on the right side. That's going to give me 30 equals 14 plus 22x. And now I've got a two-step equation. I don't have any more simplifying that I have to do, so now I can simply solve. And I'm going to solve by removing the 14 from both sides. That's going to give me 16 is equal to 22x. And my final step is going to be divide both sides by 22, and that's going to give me 8/11 is going to equal x, or I could also have written that as 16 over 22, but I always want to simplify if I can, so 8/11 is going to equal x. Now, these are a lot of steps, and it's a lot of things to remember. Make sure that you're coming back here to get assistance, and that you're asking for help in class if you need it.